Across the world, old factories sit in silence, giants of brick and steel that once powered economies, fueled cities, and defined entire generations. Today, they are shells. Rusted beams. Broken windows. Floors covered in dust and memories. But deep inside these abandoned structures, far beyond the collapsed ceilings and forgotten hallways, investigators have found machines no modern blueprint can explain. Devices left behind by craftsmen whose names were never recorded. Machines built with precision so unlikely. Many experts refuse to believe they were made with 19th-century tools. Today, we uncover 6 forgotten machines found deep inside old factories. Machines that should not exist. Machines that still defy the modern age. Number 1, the Rivington Cross-Axis Integrator. Discovered beneath a collapsed floor in an old cotton mill, this strange bronze mechanism consists of 2 rotating plates connected by an array of angled pins. When the top plate is turned, the bottom responds with a smooth, delayed motion, a mechanical integration effect similar to analog computers developed decades later. But here's the impossible part. The pins have microvariations so precise that even a difference of a hair's width breaks the motion. Modern attempts to replicate the device result in grinding, jamming, or uneven rotation. The original moves like silk. No vibration. No friction noise. Just perfect mechanical logic from an era that was never supposed to understand it. Number 2, the Marwick Harmonic Transfer Assembly. In a steel foundry abandoned for nearly a century, researchers found a tightly sealed crate. Inside was a compact mechanism of gears, pulleys, and spiraling metal bands, all connected to transfer rotational force while canceling vibration. Modern engineers call it a miracle of analog mathematics. When the assembly spins, the vibrations of each moving part cancel out, producing an impossible smoothness. Computer models cannot fully explain the geometry. CNC machines cannot carve its shapes without introducing chatter. But the original, carved by human hands, operates with a silence modern metalworking rarely achieves. Number 3, the Lysander Eurostability Wheel. Deep in the basement of a flooded locomotive workshop, investigators uncovered a brass andiron wheel mounted on a 3-point pivot. At first, they assumed it was a balancing tool. But when cleaned and tested, the wheel balanced itself so perfectly that it resisted disturbance. Even when pushed, it returned to center with flawless consistency. Its mass distribution is perfect to a degree that early machinists should not have been able to achieve. The internal curvature shows no sign of machining tools. No grinding patterns. No index marks. It is as if the wheel was shaped intuitively, guided by sound, weight, and feel. Modern replicas drift or wobble. The original remains stable after more than 100 years. Number 4, the Harrow Steam Pulse Equalizer. In an abandoned boiler house, half buried under corroded pipes, this strange cylindrical device was found with its valve seals still intact. When restored, it revealed a system of internal chambers and curved pathways designed to regulate steam pressure with extraordinary precision. Unlike modern valves that rely on sensors, gauges, and micro-adjustments, the Harrow equalizer operates entirely through geometry. Its channels redirect steam in waves, smoothing pressure spikes and stabilizing flow. Engineers compared its performance to modern systems and were stunned. The forgotten device outperformed most modern pressure regulators under low and medium loads. Attempts to rebuild it failed. Modern reproductions jam, overheat, or lose rhythm. But the original still breathes like a living machine. Number 5, the Trenton Variable Pitch Drive Gear. Found in a machinery plant overtaken by vines, this gear features tooth spacing that changes gradually around its circumference. This design reduces chatter, distributes force evenly, and allows the gear to run quietly at multiple speeds. But here is the problem. No machining marks exist. No lathe signatures. No grinder patterns. It appears the gear was shaped by incremental handwork, a technique modern machinists cannot replicate with uniform accuracy. Contemporary replicas break teeth, vibrate violently, or fail to maintain consistent pitch. The original glides through its rotation like a machine decades ahead of its time. Number 6, the Hammersmith Resonant Cutter Frame. Discovered in a woodworking factory sealed shut since the early 1900s, this steel frame houses a set of blades mounted on tension rods. When the machine is struck, even lightly, the rods resonate at precise frequencies that reduce cutting friction. This means the cutter moves through wood or metal with surprising ease, almost as if the material offers less resistance. Researchers expected crude tuning. Instead, they found harmonic relationships matching modern acoustic engineering standards. The rods are arranged in intervals so mathematically exact that digital frequency analyzers detect almost no deviation. How craftsmen achieve this without tuning devices remains one of the strangest puzzles in industrial archaeology. Modern reproductions fail to match the resonance. They vibrate incorrectly, dull quickly, or behave unpredictably. And yet the original, dusty and neglected, still produces harmonic motion when activated. Looking at all 6 machines together, a pattern emerges. These were not experimental prototypes. They were not half-finished ideas. They were masterpieces, created by craftsmen whose understanding of metal, motion, and vibration far exceeded the expectations of their era. Men who shaped steel by ear. Who corrected balance by instinct. Who tuned mechanisms by feel, not mathematics. Machines we can photograph. Machines we can measure. Machines we can scan and model. But machines we still cannot rebuild. Because precision is not only a product of tools. It is a product of hands. Hands that carried knowledge now forgotten. Hands that understood materials in ways that modern training does not teach. Inside abandoned factories, beneath layers of rust and dust. The ghosts of the industrial age are still waiting. Waiting for someone to rediscover what they once knew. Waiting for someone to understand the lost language of motion and metal. Knowledge wasn't destroyed. It was simply left behind. Deep inside old factories. Waiting. To be found again.